How much does that other pole that's not really the one on the leftmost, how much does that affect the whole thing? Because it seems like
not much, not much, not much, not much, not much. Oh my goodness, a lot, a whole bunch. Why? Because that's the one that eventually forces it to go into the right half plane. So yeah, it eventually has a lot of effect. But at first, not so much. Because if we look locally at these two, it looks a lot like these others we've seen. Come together, come apart. But eventually, this guy has an effect and bends that root locus plot into the right half plane. Which actually brings us to some other interesting things. Do we ever put on the board all of the poles that truly, really exist in our system? No, we never have a perfect model. Where do these other poles come from? Well, let's see. Anytime I wire anything up, is there capacitances I probably haven't taken into account? Because there's wires nearby other wires? So there are straight capacitances I have not taken into account. They will result in other poles. Now those other poles will be way off on the real axis to the left, but there will be other poles out there. There's always a dungeon of poles. How about, do I count for the inductance of a simple wire? Nope. Typically not. Just ignore it. It's a perfect wire. But do wires have inductance on their own? Yeah. Again, they will result in poles. Typically those poles are way out there. But they are lurking. And what do poles that are way out there eventually do to all of our locus plots? Eventually they will make it come off the real axis. Eventually they will make it bend over into the right half plane. Does that actually feel right? Because we've had several cases on the board now where I told you definitively from the root locus plot that we could turn the gain up as high as we wanted and nothing would ever go unstable. I can drive down the road as fast as I want and nothing will ever go wrong. Is that a lie? Yeah. Eventually my car gets airborne, assuming I have a big enough engine. Ask anybody who drives out on a Monteville South Flat. No, you cannot go as fast as you absolutely want, even if the simple models tell you you can. Because there's other stuff that you haven't taken into account. And if you want to go near that limit, you better start taking those into account. Okay? But we still get a lot of good ideas about what's going on locally. And that's where I talked about the centroid, the local centroid. The centroid we figure out that we say is the only one, it's really only the local one. So, a couple of things there. Is the root locus plot a useful thing to look at? Did this stupid little set of lines on the board describe what goes on in the lab with a real system? Because if it didn't, it wouldn't be much value. And we hate to tell you that what we teach you has no value. All right. Another transfer function. Open loop. Poles. Where are the poles? Open loop poles. 0. -2. -4, -8. Wow, lots and lots of open loop poles. Are there any open loop zeros?
Yes.
Where?
-10.
-10.
Yeah,
-10, because we can factor that 4 out of there. This top would be better off expressed 4 plus 4s plus 40 is equal to s times 4s, no, 4 times s plus 10, right? And in the second way, it's easier to see where that 0 is. Okay. Real axis rule says No, 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 no.
Yes.
Yes, 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 yes.
No. Yes. No.
Not there.
Yes.
Now this is weird. Because is this a begin point or an end point?
Should be an endpoint.
It's an end point. These are both begin points, so somewhere in here it must take off. These are both begin points, so somewhere in here it must take off. Okay, what's the next step? M equal 1, N equal 1, 2, 3, 4. N minus M is equal to 3. How many asymptotes do I have?
3.
Again, dividing 360 degrees up by 3, it's 120 degrees apiece. We know one goes that way. In fact, it's one. Wait a minute. How can it go that way if it ends here?
Arcs around and then comes back.
Yes, something has to come in here so that one goes this way and the other goes that way. Because this root locus line, there's somewhere out to infinity, everything is left to that one, an odd number. Neglecting all those lurking poles out there. Okay, so what's going to do? What are we going to do? Well, let's find the centroid and see if we can figure something out about that. Equals 0 minus 2 minus 4 minus 8 plus 10. Whoa, I did that fast. What did I do? Added up the pole locations. All of them are negative. Subtracted off the 0 location, which is also a negative. Subtract off a negative, get a positive, right? Divided by how? What number?
3.
Okay. 2, 4, 6, 6, and 8 is 14. 14 plus 10 minus 14 plus 10 is negative 4/3. Did I do that right? Okay. Negative 4/3. That's 2. That's about 1. That's about right about here. So here's my centroid. Oh, not tau. Sigma. Okay, what's it going to do? 60-degree angles, right? Yeah, that was probably a little too small. Without getting a protractor or figuring out what that number has to be up there. By the way, what does that number have to be? Isn't it like square root of 3 times 4/3? For a 60-degree angle. Okay. What's going to happen? Well, let's take a look at the first one here. How many root locus lines can follow this asymptote? Can this one and this one both go there? No. There is one root locus line per asymptote. Which one's most likely to go there?
This one.
Yeah, the two that are close. Now, it can go over and then come back.
Can?
Okay. That is possible. We're not entirely sure what it's going to do. But since it's so close to the centroid, my guess is it can go over. It will go over. What about these? These leave at 90 degrees. They always leave at 90 degrees. These always leave at 90 degrees. What the heck happens? Somewhere over there, because there is root locus this way, and one terminates here, and the other goes to infinity here, that is actually the other asymptote, isn't it? We don't draw it as an asymptote with a dotted line, because it's just along the x-axis or the real axis. So somewhere here, it takes off and comes back. My best guess is this is about the center. The center of these two is about the center of the circle. And my guess is that it's a nice circular look. Now that is somewhat from experience. But that's my best guess. Without looking at finding the actual breakaway point and the actual break-in point, that would be my guess. So, does this tell anything about our system? These poles here, these closed loop or open loop poles here, and then the closed loop poles which do this, are they going to be the ones I have to worry about? Which are the ones I'm going to have to worry about?
Closest to the j omega.
Yeah, and that's typically, and I have to worry about the ones that are closest to the j omega axis. So most likely I will set up my game so that these two closed loop poles are about right where? There and there. Okay. Question you might have right now is, why am I using a little red square to show where the closed loop poles are? And nobody should have the answer to that.
You're crazy, 100%.
Right?
Are you crazy? That's why the red square.
It's because I'm a closet communist.
That's on video.
They'll be hauling me off pretty soon. Actually, the communists aren't the bad guys anymore. Yeah.
A random question. If you added another 0, would that fix it?
Ah! You're thinking ahead. You're thinking ahead to like RL5 and RL6 and stuff where we actually start adding things. When you are adding the differentiator in 5b, that's what you're really doing, you're adding another 0. So, yes, but you're thinking ahead and you're saying, well, wait a minute. If I can see what these open loop poles and zeros are doing, maybe I can add stuff and make it do what I want. Okay, the reason I'm using little red squares there is because when later on you use MATLAB to do this, guess what? MATLAB uses little red squares to show you where the closed loop poles are. So I'm going to start doing that more. Now, does that tell us anything about where these are?
No.
We're not sure if they're here or here. I don't know, because the rate at which these move along the lines as you change the gain is uncertain. I don't know where those are. But it turns out those are not the dominant ones. The ones that are closest to the j omega axis are the dominant ones. So I'll probably do this, and these will end up being, I have no clue. Here, 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 here. I don't really know. I have to do some calculations to figure that out. But first, let's see if our locus looks about right. Hey! We're getting better at this. Okay, let me ask you. I assume this took off right about the center here. Was that right?
No.
Not quite. I assumed that it was about a half circle. Now, the truth of this is that I was about right about that. It just happens to be that my screen is a little wonky here. Because that's 2 and that's 2. So it has to do with that circular thing is more circular than it looks. Because of just the X and Y, the pixels. But this one turned out to be way off. It did not leave in the center here. It left way closer to here. This circular thing is not quite around the center of these two. It's a little to the left. Yes?
Will it always end up being
Aaron, right?
Yes. Will it always end up being circular, or sometimes you do get more football?
We are going to assume our first guess as circular. Now, it turns out it does become more football shaped. If it's because of this line here. If this lines were closer here, it would actually push it away even further. It would make it more football shaped. But those kind of rules that make that happen are beyond the scope of these initial rules. And we're not even that concerned, because this is, at this point, it's back of the envelope type stuff. If you really want to know exactly what's going on, what did I just say we could use to draw these things? Yeah. It doesn't matter. Okay. So, the point of all of this is I could give you a bunch of examples that are all figured out for you, but I think it's better if you do them. Furthermore, it slows the process down a little bit. And you've all been in classes where the process is going so fast you can't keep up. I just did that to my other class because I came in late and I had material I needed to cover. So those poor people, complex numbers and basic phasors in 40 minutes.
Oh, ouch.
I did promise them to do some videos. But yeah, they're not liking me right now. Okay. Tell me, do I know where the poles and zeros, the open loop poles and zeros are? One there. One at -4. One at -10. Is there a 0?
Yeah, -6.
About -6 right there. There's my open loop poles and zeros. That's what I always start with. Real axis rule says, what happens here?
Locus.
Okay, any here?
No.
Any here?
Yes.
Okay,
That -10 will end at the -6, right?
yeah. So now we start looking at beginnings and endings. Here, these two are beginnings that must come together. Probably takes off about here, but we noticed already if there are other poles and zeros, the center point isn't our best. But we're not yet sure how it affects that. Here, this one must start here and end here. And that's it. How many poles? 1, 2, 3. How many zeros? 1. So that equals m, that equals n minus m is equal to 2. Now, does that make sense? There's 2 other asymptotes. How many locus starts do I have that don't have finish lines yet? 2. Yeah, these 2 over here. So let's figure out sigma.
-4.
Let's see, 0 minus 4 minus 10 over 6, no,
Plus 6.
plus 6 over 2. Okay, 2 plus 5 is 7, minus 3 is 4, -4. -4, and then it does what?
Leaves at 90 degrees.
There, I'm down at 90 degrees, so what does this do? It's going to do something like this. Okay. So if there were no 0 right here, Nephi, would this look different?
Yeah.
I would have this one go out to infinity, and what would these do?
Straight.
Straight.
Oh.
So if someone had added that 0 on purpose to make this a better system, did they make it a better system?
Yes.
Yes.
That's right.
Waiting. Where are we probably going to locate our closed loop poles? Probably about right there and there, huh? That's probably where we're going to want to locate them. Something along that line. Let's look at what it really looks like. Like that.
Is closed loop poles, are we putting them, we're not putting them at the 45-degree point, the natural.
Very
point, is it?
commonly, yes.
Okay.
Very commonly, we will put them at 45 degrees from here. So we'll look at 45 degrees from here. I could probably put them a little further up.
Okay.
Like this. So let's see, if this is 2 and this is 2, that's that's about as 45 as I'm going to get.
Yeah.
That's 2 and that's 2, that's about as 45 as I'm going to get. Am I exactly right on with my just quick sketch?
Pretty close.
Pretty
Yeah.
close. Yeah, pretty close. Yeah.
Good question, kind of with our last one. When you said there's only one centroid, if you expand, if you start like zooming back out, would the centroid that you can see the overall behavior as you, do you get what I'm saying? Like,
If there were no other poles and zeros as I zoomed out, then that centroid would remain that centroid.
okay.
But the truth of the matter is, what I just told you is, there's always more poles lurking out there. So if we zoomed further and further and further and further out, what it would look like is all of these, as we zoomed in, we get closer and closer together, right? And eventually we see those other poles. And it would look like there's a little local up and down, but then eventually we back off that way. So that's kind of what I mean by the local centroid and even further up the centroid. So the centroid doesn't move. It just looks like local behavior follows the first centroid, which that's just those 3. But eventually, these 3 poles and 1 0 end up looking like basically 2 poles. That location, as we zoomed out further and further and further. Okay, one more we gotta do real quick, and because we go through 35. This one this one is the one I want to do because there's a problem like that in your homework. All right, real quick, a little bit different here. Now we have multiple poles at one location. All right. Triple poles. Really weird. We have a 0 where?
-8.
-8. We have poles at -1, and then a triple pole at -3. This is really kind of strange. All right, real axis rule. Anything here? Yes. Between here and here, there's a yes. Okay, now it's past 1, 2, 3, 4. Are we past an odd number?
Oh, you gotta do individuals.
So, come this way, past 1. So yes, root locus. 2, 3, 4.
No.
No root locus. The root locus out here?
Yeah.
Yeah, so everything else has root locus. Okay, what the heck is going to happen?
Weird things.
How many root locus lines originate from that pole?
1 from there, 3 from there.
Yeah. And then 3 from here. Okay, 1 goes that way. These two are going to come together. Somewhere here, so you're going to get something coming off here. So, when I have triple poles, when I have double poles, there are 2 possibilities on the real axis. If I have double poles on the real axis, there are 2 possibilities. One is, because of another polar 0 out here, I have root locus here. What will that mean for here?
You also have them there.
Okay, so there must have been some 0 or some pole. Now, the other possibility is they're the first ones I encounter, or there's an even number of poles and zeros out here, so there's no root locus here. What happens then?
It's right in between where we're at them.
They go straight up off of there, right? Because there can't be any root locus here, there can't be any root locus here, because of real axis considerations. They have to be symmetrical, takes right off. Okay, good. What about a triple? Well, it turns out a triple pole, either they take off like this, and what will be the angle between those, do you think?
120.
120. Or, for a triple, it could take off this way. So how do you know which one of the 2 is correct?
Real axis.
By the real axis rule. Because the real axis rule will set either there is no root locus here and there is root locus here, in which case it's like this, or there's root locus here and there's none here, in which case it'll be this one. Which one fits this?
First one.
The bottom one. So these take off, and they take off at about 60 degrees off from the... And then what's going to happen over here? It's going to come in at 90 somewhere here. So what do you think is going to happen? Something like that. Let's see what it actually looks like. Oh, you know what we never did was we never found our centroid and our 2 other lines. How come my asymptotes are like this? What's n minus m?
Nothing.
3.
And then I figured out my centroid, as I have been doing all along, at this, that was this, that's why these come off straight and then follow like that. Now, is my other part of the picture quite accurate? Not exactly. Getting close. All right, those are the main rules pretty well. What we haven't looked at yet is, what if I have some open loop poles or zeros that are complex? How do I handle those? Well, you got to start looking at that next. And then we're going to see how we can do other things. Okay, have I at least convinced you of the